Welcome to Brain Vision.
16.56, so we've got a standing wave on a string here. The SI units are assumed, so Y, this is in meters, X is in meters, this is 5 pi radians per meter, this is 40 pi radians per second, but we're saving ourselves a little bit of bother with writing all that out, and then the parentheses we'd need to separate the things with units from the symbols, etc., and so forth. That you just, this is a bit lazy, but sometimes laziness is okay. So we want to find the location of the first three nodes, the ones with the smallest three x values for x greater than or equal to 0. We want to find the period of the oscillatory motion of any point that isn't a node. Obviously, since the nodes don't move, talking about them having a period of oscillation is a little bit meaningless. Then we have two traveling waves that interfere to produce this standing wave. So we want to find their speed and amplitude. And then we want to find the first 3 times after t equals 0 where all points on the string have a 0 transverse velocity. So we have a number of things to do, but some of them are kind of, you do them all at once. So we want, the nodes are going to be given by sine of 5 pi x equals 0. This implies that 5 pi x is equal to 0, pi, 2 pi, etc. Which means that x is going to be 0, 1/5, 2/5, 3/5, and so on forever, or until you reach the end of the string. So then the smallest ones, we can just, add an m for meters on here and express them as decimals. And so we have 1 at 0 meters, 1 at 0.2 meters, and then 1 at 0.4 meters. And then every, 0.2 meters after that we'll have another node, but we only care about the ones with the 3 smallest x values. So every point except for the nodes has a simple harmonic motion with the frequency that's just omega over 2 pi. So omega is 40 pi radians per second divided by 2 pi. So this is 20 hertz. Now we know the period is just the inverse of the frequency. So the period of any point that actually moves is 50 milliseconds. So the two standing waves that interfere to produce this pattern are going to have the same wave number and angular frequency as the standing wave they produce. So V is omega over k. We know omega is 40 pi radians per second. K is 5 pi radians per meter. And so the speed is 8 meters per second. Now we're told that or we know that for it to produce a standing wave, we need the amplitudes to be the same. And since this tells us the amplitude of the standing wave, each one is going to contribute half of that amplitude. So then the amplitude is going to just be 2 centimeters for either of the traveling waves. Now for the time when the transverse velocity is 0, well, we know that the velocity is the derivative of the displacement with respect to time. So this is going to be negative 0.04 times 40 pi times the sine of 5 pi x times the sine of 40 pi t So now we just want the first 3 times at which 40 pi t is equal to an integer number of an integer multiple of pi, non-negative integer, pi, etc. So this means that t is 0, 1/40th, 2/40th, etc. So we have 0 seconds. 1/40 is 0.025 seconds. 2/40 is 0.05 seconds. And so those are the first 3 times at which everywhere on the string the velocity is 0, or the transverse velocity. And so this is all we need to find.